Okay, so hi everyone. Our topic for today's video will be about dimensional analysis or factor labeled method. So, magdimensional analysis na naman tayo. So, let's not forget our basic math from our previous lesson. So, let's get started. A dimensional analysis or DA or factored labeled method is the use of numbers in the form of fractions. So take note that we are going to handle fractions or conversion factors. We have already tackled this one. To convert one unit of measurement to another for cancellation of units. So I may have assumed that you already know how to conceal units. The main idea is to cancel out same units appearing in both the numerator and the denominator until you are left with the target unit. So in our module 1, we are going to recall that and also don't forget those conversion factors. So we're going to cancel out common units in the denominator and the numerator. Then perform the operations. You will arrive at the answer of your target unit. So today we are going to use the dimensional analysis. Note that they are often quantified in terms of the atoms and or molecules of their reactants or products. However, using the number of particles or atoms in calculations and working on a chemical reaction are a tedious process. So chemists use simpler physical quantities such as mass and volume. Therefore, you need dimensional analysis to convert mole to mole, mass to mass, volume to volume, mole to mass, mole to particles, mole to volume, and vice versa. Kato lang. Examples ahead illustrates how dimensional analysis is applied in converting one unit of a substance to another unit. Now, we have here example number 1. How many atoms are there in 1.07 mole of Na? Now, we are asked by the number of atoms. First, we are going to analyze the problem or question. So, to relate the number of atoms to a mole of sodium, you need Avogadro's number because we have already the constant, which is 6.02 times 10 raised to 23. Now, you are going to start with the given information to solve the problem. Of course. So, we have, the question here is, we don't know yet the number of atoms of Na, but it is equivalent to 1.07 mole of sodium. So set up the conversion factor. To convert 1.07 mole of sodium to atoms, use the conversion factor with the denominator the same as the given for cancellation. So dapat you need to have the conversion factor that would possibly cancel out the given the other given, so that your target unit will be left. Okay, so we have here your conversion factor, 6.02 times 10 raised to 23 atoms per 1 mole, diba? They are still conversion factor, they are equivalent. Set up the mathematical equation. So we have number of atoms equals 1.07 mole of sodium times the conversion factor, 6.02 times 10 raised to 23 atoms of sodium over 1 mole of sodium. So cancel out mole of sodium. Then we will get 6.44 times 10 raised to 23 sodium atoms. And that is your final answers. Okay. Next, we have example number 2. So calculate the number of atoms present in 1.00 times 10 raised to 2 grams of silver or Ag. So what are we going to get is, the question is, we are going to get the number of atoms of sodium. Given is the mass of sodium na nun, silver di ay, silver. So convert mass to mole and then mole to atoms. Okay? This mass is, we are going to convert it into mole. That is your first conversion. So start with the given information to solve the problem. So we have here the unknown number of atoms equivalent to 1.00 times 10 raised to 2 grams of silver. So we have here to convert the we are going to set up the conversion factors first. To convert the 1 times 10 raised to 2 grams of silver to number of atoms, so use this conversion factor. So what is this 107.87 grams? This is what? Again, this is the molar mass of silver per mole. Diba? Grams per mole. 107.87 grams per mole of silver. Then we have another conversion factor. We have 6.0 times 10 raised to 23 silver atoms over 1 mole of silver. And we have here, or pwede nating ibaliktad, 1 mole of silver is 6.02 times 10 raised to 23 silver atoms. Now, okay, diba? We are going to convert mass first into mole. So, we are going to use the mass given, which is 1.00 times 10 raised to 2 grams of silver. We are going to use this formula, which is N is equivalent to M over M, where N is the mole, M is the mass of the weight of substance, and M is the molar mass is in grams per mole. Diba? Molar mass is just simply the mass over mole. But then, since we are going to get the number of mole, so yun yung gagamitan natin. N equals letter M, small letter M over the mass over the molar mass. Okay? So the mass given, we have, to get the number of mole of silver, we are going to have here equal to the mass 1.00 times 10 raised to 2 grams divided by the molar mass. So we have already 0.927 mole of silver. Since we already have the mole, now we are going to get the number of atoms. So let's get the number of atoms by simply multiplying our calculated answer in moles by the conversion factor, which is the 6.02 times 10 raised to 23 silver atoms divided by 1 mole of Ag. So atoms of Ag, simply multiply these terms, and we come up to the answer, which is 5.58 times 10 raised to 23 silver atoms. But then this problem, we can actually solve it with a single step, as long as you know how to analyze your solution. It's because accuracy is needed, and careful tayo sa pagsosolve. So this is the single step solution, and come up with the same answer, which is 5.58 times 10 raised to 23 silver atoms. Now let's go to the last example. So calculate the number of atoms present in 8.21 times 10 raised to 1 grams of oxygen gas or O2, as well as the volume in liters it occupies at standard temperature and pressure. Step 1, we are going to analyze again the problem or question. So our analysis will be about converting mass to mole, since we are given with the mass, then mole to number of atoms, since we are also asked with that, and then the number of atoms to volume. Okay? So start with the given information. Again, ano number of atoms and volume of oxygen gas equal to 8.21 times 10 raised to 1 grams of oxygen gas. So set up the conversion factors, or you list down the helpful conversion factors to the number of atoms occupied. Use the following conversion factors. So we have here 1 mole of oxygen gas is also equivalent to 32 grams of oxygen gas. So simply this is just the molar mass. Okay, 1 over 32 mole per gram, or just 32 grams per mole. We also have the 1 mole, the Avogadro's number nga conversion factor. We have 2 oxygen atoms over 1 O2 molecule. Right? Diba, in the molecule O2, we have 2 oxygen atoms. Okay, so that is also another conversion factor. And then for the volume part, we have 22.4 liters in 1 mole of O2. Okay? So, let's set up the mathematical equation and cancel out all unwanted units. So, in a single step, we are going to get the number of atoms of the oxygen gas. So, given 8.21 times 10 raised to 1 grams per of oxygen gas, we are going to multiply it with the reversed molar mass so that we can cancel out grams. Then, multiply it with the conversion factor of the Avogadro's number so that we can cancel out mole. And then use the, another conversion factor between atoms and molecules so that we can cancel molecules. So, we come up with the answer of 3.09 times 10 raised to 24 oxygen atoms. Kasi atoms yung what is being asked. Now, let's go to the volume. To the volume of the, So, since the conversion factor given, we are going to use to get the volume is just the 22.4 liters per mole of oxygen gas. So, we are going to use the mass first, then multiply with the molar mass para ang matira natin na unit is the mole. And then use the conversion factor that indicates the volume so that we can cancel out the mole. Okay? Now, we come up with the final answer of 57.5 liters. So, that's very easy. Okay? I hope you understand the following. And for your activity, kindly answer the following problems. Good luck.